welcome to Defender Fridays. For anybody that's joined us for the first time, the idea behind Defender Fridays is to bring together like-minded folks in the information security space. And as I've actually mentioned many times before, it doesn't just mean defenders, right? Because at the end of the day, it takes many different disciplines and focuses and skill sets for us all to be successful in this mission that we have of defending enterprise and organizations kind of in our day jobs or as hobbyists. And we're making good on that promise today by bringing on a more offensive focused guest. So Tim Fowler's joining us. Tim's over at Black Hills InfoSec. And he's done some really interesting stuff in his career. Matter of fact, I just got a little bit of a backstory on you, Tim, that I'm interested to dive into on this call.
Let's
Would
go
love to
for
hear.
it.
Yeah, yeah. I heard that you've done some work with space assets in security capacity.
A little bit, yeah. It's really been my focus for the last 15, 18 months is really taking my experience and my skill sets in offensive security, traditional, I'm going to call it terrestrial environments, uh, penetration testing, red teaming, things like that, and really looking at how we can apply those same concepts into space systems to really be able to not just protect our space assets today, but really as we invest and double down in space, really securing our future in space.
That's freaking cool. I think most people would agree that's a pretty cool use case. And as I understand it, you're a founder of an organization called Ethos Lab, where you guys
Yeah.
produce educational technologies for hacking spacecraft. Okay,
Yeah.
expand on that a little bit. What's that about?
All right, so Ethos Labs is like I said, it's a company that's really just focused on cybersecurity education from the context of space systems, and so Ethos actually stands for Educational Technology for Hacking Orbital Spacecraft because everything in aerospace has to have an acronym, even if it doesn't make sense. But in this case, it does, and so it was really just kind of a combination of the research that I was doing. And I wanted to be like, I went down this rabbit hole where I sent John Strand an email. I was like, hey, I want to build a CubeSat lab for Wild West Hacking Fest. And if you know anything about John, he's like approved. Like that was it. Like it's just and so it's like, well, now I actually have to learn how to do this and figure out like all of this stuff to make it, accessible because one of the problems that we have within when we think about like space and operating space is it's out there. Like it is a foreign concept to most of us. But when you put something in front of a person, put their hands on the keyboard, they start interacting with the system. They're like it starts to click. It is like, wow, this is really just a high latency network link, and it's just a computer. Like it's fundamentally just computers. And so when you start to break it down into those basic foundational elements, now we can start understanding like, hey, what if I can I make it do a barrel roll? Can I, do all this other stuff? And so yeah, as I started developing that and stuff, I realized like, there's a big kind of void with especially within cybersecurity, but also within the space industry of where the space people, they know space, they don't know security. Security people, we know security, but we don't understand space. And so the goal with Ethos Lab is fundamentally to meet both sides of that equation right there in the middle so that cybersecurity people can talk space and understand the environments that we're working in, and then inversely the space people can understand like when we're coming approaching a cybersecurity topic in a space system, here's what we're doing, here's why we're doing it, and just really it's about facilitating that conversation.
That is incredibly cool, man. I mean, it's rare, I think, that I hear somebody that's getting involved in something that is so unique and so interesting. Because I think most of us kind of get stuck in sort of the mundane of what do information systems look like today, right? They look like traditional on-prem environments with the boundaries, and then yes, we got cloud to think about and worry about now, SaaS applications. You're talking about spacecraft. I think that's super cool. Tim, I'm curious because forgive my ignorance here. Is there a career track here for folks that are interested in this concept? Like, is there work to be done, or job postings out there that folks could look for that get to
uh
do this kind of stuff?
so yes and no. It's yes, in the context, it's typically happening in a silo, typically internal to organizations that are operating in the space domain. There's not a lot of third party kind of secure. One of the questions that I still ask myself to this day, and I don't have a definitive answer on this, is like I look at what happened in the ICS world, like
Yep.
15 years ago. And then you have an organization like Dragos and
That's
Robert
right.
Lee and stuff. It's like, and they've become like that is the company that you're going to go to when you're dealing with ICS cybersecurity stuff. It's like, who is going to be the Dragos of space? And that's something that we're going to have to happen. And with the democratization of space, it's no longer just the NASA's and the JAXA's and the ESA's that are playing in space. We have everybody and their brother that can afford it, and it's getting more and more cost effective, are putting things into orbit. And so we're going to have third parties looking at this from a security perspective, not just the internal teams and stuff, just the same way that we looked at the ICS world.
Ever since I learned about your background here recently, I started a little internal chat with my colleagues here at Lima Charlie. I'm like, we have got to be the first EDR in space. Like that's got to become a company goal. We've got to make.
I have a way to make a happen if that's
Let's
really the goal.
let's do that.
Like we can
Let's
do that. Like I mean,
let's
it ain't going to be cheap. It's the
sure
success rate may
sure.
or may not be. Like I was joking with one of the things that I'm hoping to show off at Wild West Hacking Fest is this year is more technology demonstrations and stuff like that. But basically, I'm wanting to use an RF link to one CubeSat, and then that has a infrared laser
All right.
communication system to a second satellite. Well, over that optical link is running PPP, which means we've got IP, which means I'm going to run a interpreter session on a remote satellite through a relay.
Brilliant.
And
Brilliant.
the answer to everybody's question is because I can.
Yeah,
Like
of
that's the
course.
like why? Because you absolutely can. And is it going to work the way I want it to? Probably not and stuff. But just to get people thinking, it's like, hey, like there's some really really interesting opportunities, and being able to play. But I like in that email I sent to John, I actually first said like, hey, can we put a satellite into orbit? And then I went into the rest, and the email just that I got back was just approved. I probably should have pushed a little bit heavier. It's like, which part's approved here? Like, are we going to go to space? Because
And
it's
more
like I was like
importantly,
I can see it now, like Cobalt Strike in space.
yeah,
Like that
yeah,
that headline will pay for whatever the expense is and stuff. But no, like one of the interesting things with space assets and space security is it's so heavily focused on detection and response capabilities because the attack vectors are very nuanced and unique and stuff. But how do we operate within the constraints? Like how are you going to put an EDR solution
right.
in a 10 by 10 by 10 centimeter CubeSat? You're probably not. But if you scale up a little bit, you may actually start to, we're seeing machine learning and AI actually flying on birds for the purposes of incident response and detection. And stuff. So like it's, if you guys aren't gonna do it first, somebody's going to.
Wild.
I don't mean to interject here, but Tim, did you say it was about 125K to put a CubeSat up in space?
Yeah, it's a so probably a closer number is probably about 160. It would be on the absolute low end, depending on if you're able to do like a rideshare mission. If you could want to think of it like Uber for space, SpaceX has rideshare missions. Rocket Labs has entire launches that are just dedicated to CubeSats and small satellites. So that cost is coming down drastically. And so realistically, for I would say $200,000, you probably actually could get an off-the-shelf components, assemble it, and write the software, do your own implementation, and get it launched. Now it may be 2 or 3 years before you can hit a launch window,
I mean,
or something like that. But theoretically that would be possible.
that's cheaper than a two-bedroom house in most cities these days.
Yeah.
Hey, I don't want to miss this one. So John Woodling asked a question in chat. He said, "So how do protocols and systems differ for these types of systems? I would think it would also vary by system. So like weather satellites versus comm satellites versus Elon's Model 3 floating around. So anything on kind of how the
Yeah.
protocols differ?"
Yeah, so like most cybersecurity answer, it depends. There is there's an organization called CCSDS. It's the Consultative Committee for Space Data Systems. And they have defined a bunch of kind of standards for things like such as space packet protocol, space link protocols, and a bunch of stuff. That pretty much this is the accepted standard of how communication is going to happen. Most of it's driven towards interoperability, both within a single launch apparatus or single space system, but also from company to company and stuff. Standards are good. But there's also a lot of YOLO protocols out there that are completely proprietary. A good example would be Starlink's their interconnects or their crosslink, their satellite to satellite communication protocols are completely proprietary to say. And so you've got some standardization, you have others that are not. The biggest thing that you have to really kind of adjust to when you're thinking about protocols and from the space side of stuff is like everything has to be hyper efficient because you have such small link budgets, and in some cases you may only have if you're in low earth orbit, your orbital pass over your ground station maybe 10 minutes, and then you may not see it again for 3 or 4 orbits. And so you've got to figure out how I'm going to get down data up and data down in that amount of time, dealing with all the radio propagation and just the issues from that perspective. And so it's like we have to think about. I mean, it's like I've got an example for one of my classes where it's like I've got a single packet, it's 255 bytes that contains 84 commands in it. 84 instructions for that satellite to do. And it's literally at the bit level. It's like if this bit means it is 1 or a 0, do this all the way through the subsystem chain.
That's wild. Two things. So one, just kind of a side note, I was really fascinated to learn about how Starlink's ground terminals do beam shaping.
Yeah.
And for anybody that's even remotely interested in like RF or SATCOM or any of that stuff, there's a YouTube video that talks about how that flat panel actually leverages this incredibly brilliant concepts to shape the beam to be able to aim a very tightly focused beam anywhere in the sky. So it's a flat panel, but the beam is by no means just like a unicast or like a big wide array. Really cool. But more relevant to the topic of security in space systems. So there's precedent for this, right? When the Ukraine invasion began, remember one of the very first things I think that was starting to make coverage across news and social media was one of the first things they did before I think they dropped a single bomb. They took out satellite communications within Ukraine. They did that with conventional cyber warfare means by penetrating into ground data terminals and and overriding and I don't know, zeroizing their configurations, otherwise just basically taking them out of commission. Like that was kind of wild, right?
Yeah, and so I mean, so that's the Viasat attack on the KA sat network. That is going to be the kind of the Stuxnet as far as like case study for years and years to come, because there's aspects of that attack that a lot of people don't actually know that it was. You're 100% correct that they actually came in over the internet. Originally, it was thought it was a Fortinet vulnerability that they were able to compromise, but Viasat came out and said no, it was just compromised credentials that they were able to get in over the internet into the management network, work their way through the management network using traditional lateral movement capabilities, landed on a TFTP server that happened to be the TFTP server for serving firmware to the satellite modems across the satellite links. So they created a custom wiper, uploaded that to the server. All the terminals like, oh, we've got new software, and they zeroed themselves out. And that's the side of the attack that's really talked about. But there was an entire second attack vector that was actually coming from the user segment. So space systems are comprised of 3 primary segments: the ground segment, that's pretty obvious, the space segment here again, and then the user segment. And that's what you can think of like the payload, the mission and stuff. So like take Starlink. If you're a Starlink user, that internet connection, that's the user segment. But what they did is they actually manipulated and basically attacked the AAA authentication and DHCP configuration within this entire network to perform a wide scale denial of service attack. Basically, once the modems were knocked offline that weren't subject to the wipe or whatever, they couldn't get a DHCP request. And that went on for weeks, because they would figure out. I was like, oh, they're going after this, they're doing this. They would fix it, and then the adversary would have another way that they could exploit another kind of configuration vulnerability, and that was going on simultaneously.
So that's that's an awesome backstory to kind of hear some of the other attacks that unfolded there. And one thing that becomes apparent to me then, very much like IoT. I love that you used IoT as kind of a parallel to this, because it is very similar in a lot of ways, right? Like IoT is kind of this very specialized silo of knowledge and expertise that I would say the wider security community probably doesn't have. However, if you go back and look at some of the major sort of IoT centric breaches, right, ICS related breaches, many of them started through conventional IT environments, right? So, and the same thing is true about like the Viasat issue, is that like it wasn't some super space age like satellite specific hack that took place here. No, they got in through conventional IT, conventional hygiene failures, right? Like
Mhm.
reused passwords and insecure TFTP for firmware, right? And then obviously there's probably no firmware signing checks going on here, so they were able to push that payload, right? Like there are so many things here that honestly we have decades worth of experience with in just conventional cybersecurity. So clearly there's overlap here, right?
There's that, and that I would say it's 97% overlap. It's now that last 3%
Yeah.
is extremely significant, and stuff. But yeah, like if you took the space element out of the Viasat hack, it reads like every other breach report that we've read, and stuff. And it's the landscape's getting even more interesting, if you will, because we're making some decisions here. Like space is going to the cloud. And what I mean by that is the all of your major cloud providers, Amazon, GCP, and AWS, or Azure, all have what's called ground station as a service. And what you do is you deploy your your ground station infrastructure, your mission control systems, and all of that stuff into one of these cloud platforms. You hook into their ground station as a service, and then you're able to utilize all of their antenna systems across the world, to be able to do that without having to build your own ground stations and stuff, because that's limiting, because if I only have so much line of sight and getting to the physics of it. And so we've removed a lot of the physical security elements of that, but now we have all of our space data, including command and control, in these cloud environments. And I don't know about you guys, but coming from my perspective, I don't see a lot of people doing cloud right. Definitely not doing it well.
Like
And so now that, Susie and HR that gets device code phished, and because your tenant's not set up correctly in Azure and stuff, now a threat actor is actually able to work their way all the way into this environment, into the Azure console, where they're going, oh, well, this is interesting. And now they have potentially direct control of all of your space assets.
wild, man. That is incredible. But yeah, it is interesting to start to see how the terrestrial networks are starting to blend with satellite assets, when it, like you said, it's literally it's a service now in the cloud, in cloud providers. So that's pretty incredible stuff. And
Um,
yeah, go ahead, Charles,
Sorry, I was
Christopher.
just gonna. One thing that I think it would be great for Tim to kind of share was we were talking about CubeSats and how they're kind of like designed like Docker containers, and then you look at like the heavy lift rockets that Amazon's building, and they're built with like compute as a service. So we see a lot of these software engineering concepts being built into these hardware systems that are going to be used to bring things into space.
Yeah, I mean, there was a joke earlier in the chat that's like space runs on Linux because you can't open Windows, and that's 100% accurate for on multiple levels. But when you look at it, the way kind of space software has changed and how our firmwares and stuff like that, the majority of systems now are Linux based. Now they're specialized real time kernels that have been hardened and things like that. I heard a number. I don't know if this is 100% accurate, but on any given Falcon 9 launch, there's over 2,000 Linux kernels running on that rocket at any given time, which is just absolutely insane and stuff. But part of it is, we look at space is kind of going to this commodity kind of thing. And you talked about like my comparison of using CubeSats as like Docker containers. And that's really kind of what they are, is that they're just really small. I don't know if it'll focus, but they're like this size right here. And it's made it a lot more interesting. We've seen Raspberry Pis flying in space, like the Pi Zeros have actual space heritage, which is just fantastic. Arduinos and things like that. Like space is becoming commoditized, and so the things that we're familiar with, Docker runs in space, Kubernetes is in space, specifically like K3, and stuff. And so it's definitely like this kind of like that. Once you can wrap your head around, like it's just out there and we can't like go and hit the reset button because it's really expensive to send somebody through astronaut training and then have them fly up and then push link up and push the button. Once you accept that aspect of it, it just becomes computers and networks and things like that. It's just operating in an extremely hostile environment and being able to account for that.
I gotta bring up something just because it's so recent, but I don't know if anybody here follows the Voyager missions, right? The two satellites we kind of sent off into deep space with kind of a time capsule of humanity, which is fascinating. So if that's not something you know about, you should absolutely go check it out. But the reason I bring it up is because I don't remember how long ago it was, but I don't know, some number of months. Tim, you probably know, we inadvertently lost control over one of those spacecraft, and just the other day, like on the 22nd, I think NASA announced that they were able to regain control of that Voyager. So it was kind of
Yeah,
wild.
well, and so there's actually been a lot of different instances or issues with that, because there was one where we just basically, since we were pointing our systems off by minuscule amounts. But this most recent one to me is just absolutely incredible. They actually had a chip fail on the spacecraft. I mean, this launched in what, 78? So it's like this whole system is older than I am. And the space nerds slash wizards at NASA figured out, it's like, oh, we're just going to reprovision all of these functions to other chips, and we're just going to send this hot fix 15 billion miles away and hope it works. And they got it right.
That's wild. Now, okay, so then correct my understanding, because I thought that there was a mistake in a control that was sent that kind of put it just slightly off of
So
its
that was the older one. That was late last year, and they
got it.
fixed that.
Oh, okay.
And then this most recent, I mean, it just was announced like earlier this week, that's what they had done, and it's a
Yeah,
45-hour round trip
right.
to see if it actually worked.
And it's there's a real world analogy, like there's a cybersecurity sort of parallel to that, right? It's like when you're SSH'd into a system making firewall changes, right? Like it's like the
Is
riskiest thing. It's the riskiest thing ever, because one wrong move, boom, you're out and you're not getting back in. And that's basically what they did with the Voyager.
Yeah. Yeah, and I don't know the details of like the actual like subsystems or stuff, but like the fact that they're like, well, we've got this hardware, it's kicked the bucket, and someone's like, well, we've got a few spare cycles, and that's really what this comes down to. Like from
Yeah.
a hardware perspective, everything there's not much flexibility and stuff for them to be like, okay, we're gonna carve out sections in these other systems. Um, is just but more impressive to me is that they designed a system in the 1970s
Yeah.
to have that much flexibility. We can't build networks that are that flexible in 2024.
Oh, we can. They're just riddled with 0 days. Um, yeah, yeah, no, it
We
is
use our Palo Altos to protect our Cisco's to protect their Fortinets.
it is wild. But all right, so Tim, with the last couple of minutes we have here, because this is such an enthralling topic, like if there's anybody here that would like to learn more, get involved, get hands-on, get some training, where would you recommend folks go take a look at first?
I do teach a class called Introduction to Cybersecurity in Space Systems with Anti-Siphon. I think there was a link posted in chat for that. So I would
Excellent.
definitely I'm a little bit biased. I do have teaching a class at Wild West Hacking Fest that is a little bit unique. It is that class, but we're actually teaching it on hardware that you're going to get to take home. So you're going to actually have your own CubeSat and ground station hardware that you're going to be able to take and continue to learn and things like that. There's another individual out there, Angelina Savoy, who has a aerospace hacking satellite class that you can take through Pentest Magazine. And she's got a good bit of content out there as well. If you're interested in kind of getting started with some of this stuff, I did a workshop at HackSpaceCon a couple of weeks ago called BIOS. It stands for Bring Your Own Satellite. And everybody that showed up, not a single one of them brought their own satellites, which was quite
Ah,
disappointing. It was in the title.
students
But you
never
but
read
you
the
can
instructions.
find that at bios.ethoslabs.space. And there's it basically walks you through setting up a virtual lab using an open source command and control system called OpenC3 Cosmos, and building a Docker container that uses NASA's core flight system, which is a legitimate flight proven flight software, and then also a couple of virtual satellites that you can play around with.
you just you just created a laundry list of things that I'm going to have to make time to figure out and do now. That's awesome. And I know that I had the same thought that John posted in chat when you were talking about your students getting like their own little CubeSat. He goes, "Oh my God, what?" And that's exactly what I
Yeah,
was thinking. I was
yeah.
like,
So
"Dude, I'm
this
coming."
is actually this here's the I'm actually designing an entire new frame structure from mechanical all the way up. And so this is the mock-up prototype to make sure all my tolerances are going to be fine and stuff. And yeah, so it's good. It's actually interesting because I'm using LoRa. If you're not familiar with it, it's long range. It's an IoT protocol. It is not designed to be used in this methodology, but we make it work. And it's actually the perfect technology to make it work. In fact, I just bought another CubeSat, and this is the absolute coolest one that you can buy. Like it's from an actual aerospace company. They're utilizing the same communications because it inherently has a link limitation, and so you have to be able to work around that, which is just absolutely awesome.
Yeah, Tim, as soon as you said Laura, I freaked out. Whitney knew I was about to because I just got into Meshtastic. And so
I've
that's a
yeah. So I've this is one of the Haltech.
yes.
Yeah, and so and that's something else that I've been looking around is actually putting these CubeSats, having the option to integrate them into a LoRaWAN,
Amazing.
and so that you could actually control them over the internet.
That is too cool. That is too cool. All right, man. Well, hey, I really hope you'll join our Slack because I'm sure folks are going to have other questions and it'd be great to get some more of your resources and links. But hey, real quick, folks, before we wrap up for the day, I want to do some repping of the home team, Lima Charlie. We wanted to share with this audience as well. So for those of you that don't know, Lima Charlie, we run our own security conference once a year. Had an amazing time at our event last year. It's called Mission Control. It's going to be held in Arlington, Virginia. We're slotted for October 2nd through 4th this year. And we have just recently posted a save the date. You can go, you can register, and then you can get in there and secure your spot because it's not a massive venue. So we kind of have to limit the RSVPs. So you definitely want to get in there and secure a spot if you'd like to go. A lot of awesome folks are going to be there giving some really cool talks. Hey, Tim, thank you so much. This has been probably one of the most unique topics I think we've ever had on this show. Really appreciate your time, your
I
insights.
I love it. I will talk about this forever and ever and ever. So you give me a platform and I will talk.
Fantastic. Well, everybody, thanks so much for joining us today. Join Slack. We're not only going to post some links to the content from chat, but also we'll announce the winner of the shirt for this week. And to everyone else, have a great rest of your day, and we'll see you next week.